Good day, students. I hope you're all doing well. So, today we'll be looking at fractions as constants, fractions as exponents in binomials. All right. So, without further ado, let's get into it. We have x minus 2 over 3, x plus a third. Now, with fractions, we know that the numerator is over the denominator. So, when we multiply fractions, this is a d. So when we multiply fractions, the numerators are going to multiply with themselves, and then the denominators are going to multiply with themselves. So having that logic, let's get back to our question. First, FOIL, right? First, outers, inners, loss. First up, we have x times x plus x times our third plus negative 2 over 3 times x plus negative 2 over 3 times 1 over 3. Now, what is x times x? X times x, that is x squared. Signs gives us a positive. Now, this is x times 1 over 3. Well, this x, we can say that it's over 1. Why? Because anything divided by 1 will just give us the numerator again, right? So, x over 1 times 1 over 3. That is x times that 1, which just gives us x. And that 1 times 3 just gives us 3. Just gives us 3, right? Before we put that sign in, that's a negative and a positive. We have a negative over there. Same thing will apply here. 2 times x, that will give us 2x over 3 times that 1 underneath. That is going to give us 3. Again, we need to bring in we need to check first. That's a negative and that's a positive. That is a negative. Now, same thing applies, numerator, numerator. 2 times 1, that is 2. 3 times 3, that is 9. Okay, so we look at the like terms. That is x squared. That is just a regular x. That is also just a regular x, and that's our constant. Do we have another x squared? No, we don't. We just bring that down. We look at our like terms, right? This is x minus 2x. If we look at the denominators are the same. And that is good. When the denominators are the same, that means we can just look at the numerator. All right, we can just look at the numerator. We don't need to make the denominators the same and go over that whole process. So what is x minus 2x? That will just give us negative x. But it's all over what? It's over 3. Why? Because those denominators are the same. Then we have our negative 2 over 9. And that is how we solve these kinds of questions. So let's look at our second one. Our second one, we have x to the power half plus y to the power half, 2x half, 3y half over there. Okay, same concept applies. First FOIL, why? These are binomials. All right, these are binomials. First look at our first outers, inners, then loss. Then multiply. X to the power half multiplied with 2x to the power half as well, plus x to the power half multiplied with 3y to the power half, plus y power half multiplied with 2x to the power half, and then we have 3y to the power half multiplied with y to the power half. Yes. Now let's just multiply what's in there. So we know that the constant is 1, so 2 times 1, that's just 2. Now, x to the power half times this x to the power half. We know that when you're multiplying variables, we just add the exponents. So half plus a half, that gives us 1. Plus, yes. And then we have 3 times 1, that's just 3. Now, x times y, we just leave it like that, right? We just leave it like that because these are not like terms, so we can't multiply them per se, right? We can't do anything with them, right? Then, like, how can I explain this? They don't do anything to each other. We just leave it like that. We just leave it like that. That's x to the power half and y to the power half. We just leave it like that. They are multiplying each other, yes, but they won't affect each other in such a way that like we have to add the exponents. No, we don't do that. And then we have y to the power of half, and that will give us a positive. Again, we just bring our 2 down. That's a y, that's a x. We just leave it like that. We just leave it like that. We just bring it down. And then we have a plus again. 3 times that 1, that's 3. Now we look at our variables. This is y to the power of half. That's y to the power of half, right? So what do we do with the exponents? We just add them. Half and a half gives us 1. And then we check at our like terms. This is x to the power of half, y to the power of half. Same thing here. So what we look at, we just add the coefficients. All right. So we have 2 to the power of x. That's 3 plus 2. That is 5. X to the power of half, y to the power of half, plus 3y. And that is it. That is it. You know, that is it. Let's look at our next question. We have x3 over 4 plus y half x minus, yes, that is what we have, right? And now we just look at what we have and then we FOIL it. Check the first outers, inners, loss, same steps, and then we multiply the first. We look at our outers, then we look at our inners, and we look at our loss, and we look at our loss. Yes, let me just make that perfect. Now, same base, we just add the exponents. What will that give us? That will just give us 1. You know, 3 quarters plus 1 quarter, that will just give us 1. Now, that's a positive, that's a negative. We have our negative over there. And then these variables, they are not the same. So we just bring them down because we can't really do anything with them, right? So they are just going to multiply each other again. Yeah. What is happening with my writing today? Yes, that's a half. And then we check our sign and we get a positive. And then same thing, different variables. So we just bring them down. We move on. What do we have? We have a positive, we have a negative. So we just bring our negative there. And now a half plus a half, same base, half plus a half, that will just give us 1. All right. And then we check if we can simplify further. Can we simplify further? We have an x over there. That's one term. Now this is x to the power of 3 quarters and multiplied with y to a half. That is just one term. We look at this as one term. We look at this as one term. Separate terms. These are separate terms. So just because there's an x there and an x there, that doesn't mean we can add these or subtract these. Why? Because this is multiplied with a y. So that just gives us a different variable. That's a different term, compared to this. Same goes over here. This x is to the power of a quarter. and that's to the power of 3/4. So are those the same? No. The y's are the same, but the x's aren't. So we are just going to treat it as if they are not the same terms. These are unlike terms, all right? And then we have a y there. So we can't simplify any further because we don't have any like terms to add to each other. And that is it. That is how we solve these fractions as in constants or as in exponents, right? We need to fold first our brackets if we have binomials, okay? And then we we simplify further here. We check at the variables, and then if the same base, we just add. We obviously look at the sign before bringing that down. We know that's a positive, we know that's a negative. That will give us a negative. And when we have different variables, we just bring it down, right? We just bring it down. And then what else? You just check after doing all of that. You check, do you have like terms? Do you have like terms in this case? No, you don't. So you just leave it like that. And that is all for today.